my name is Sabrina Heisenberg. I'm from Berry Science Lab, and today we're going to do the Euler characteristics of a projectile plane. I'm so sorry. Anyways, this is a projectile plane. This is what the normal projectile plane looks like. And its equation is AB, but we also have the two-gun projectile plane. It looks like this, and it goes in the same direction, just like this normal projectile plane, and it goes AA. Now, let's label these twists. AB. Now, let's start the traversing, like the, if you watch combinatorial surfacing. Anyways, let's start with the top of A. So, this is the top of A. I'll give you a easy reminder to guess where the top of A is. The top of A is always where the arrow is pointing. So in this case, this is the top of A, but this is another top of A since the arrow is pointing there. Now, both of them are the bottom of B, but these are both the top of A. So we have to both label them 1. We cannot label them differently because they are the same points. What about these two? Well, these are the tops of B. The top of A is the bottom of B. This top of A is the bottom of B. So the top of B, this top of B, is the bottom of A. So we have to label it differently. We cannot label it as 1. We have to label it as 2 or something else we would like. We'll have to label it as something else. And since this is also the top of B, but the bottom of A, we can label that 2. How many 2s? Oh my goodness! Chi. So anyway, the Euler characteristic represented by chi is the number of vertices minus the number of edges plus the number of faces. Remember, the vertices, this is not a normal square. This is a projective plane. So we're not just going to put vertices 4, edges 4, and faces 1 since it has 1 face. There are two vertices minus the number of edges depends on how many letters we use. So in this case we used A and B, and this had the same mechanic as the vertices, and the faces is just normal. There's 1 face in the square, so 1. And that adds up to a total of 1. Now, how about the two-gun projective plane? That's going to be interesting. But it's also pretty easy. So, this is the top of A because it's pointing up there. But that also means that this is the top of A because this is pointing there. So we can label this 1 or any other thing you want, but we have to also label this one since they're the same point technically. Because this is the top of A and this is also the top of A. So they're technically the same point. So, how do I draw chi? Chi is equal to V minus E plus F, as I said. So that's vertices, 1 number used, and that is 1. How many 1s? Oh my goodness. So 1 minus the edges. The edges depends on how many letters we use. In this case, we only use A. So So 1. How many 1s are there? And still the face is 1 because the inside of this is 1. And that adds up to a total of 1. 1, 1, 1, 1, 1, 1, 1. How many 1s are in this? Chi, the orientation, which looks so bad, and the boundary. So the Euler characteristics, we know it is 1, so we'll put 1. We cannot orient it, which means we cannot go around it, so that it means 1. If we could orient it, it would be 0. And it had no boundary, so technically it's